We are going to go ahead and start the C6 lesson on this slide, and we're going to check to see if these statements are true or false. In order for the statement to be true, both inequality statements need to be true, otherwise it's going to be false. So for this first one, it says 1 is less than 5, which that part is true, and 1 is greater than negative 2, which that part is also true. So this first problem, it would be true. Here we have 1 is less than 5, which is true. 1 is greater than 6, which is false, so this statement is going to be false. Here 1 is greater than 10, that's false. 1 is less than 0, that's true. But because 1 is false, we're going to say that this statement is false. Next one, 5 is greater than negative 4, true. 3 is greater than 0, true, which makes this whole statement true. Since these ones are or, only one of them needs to be true in order for this to be true. 10 is less than or equal to 10, true. 12 is less than 4, this one's false. But because this part was true, we're going to say true. Negative 6 is greater than 8, this is false. Negative 2 is less than negative 7, this one's false. Because both of them are false, our answer is going to be false. It says, given the set of numbers negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, list the numbers that are either greater than negative 1 or less than negative 1. So the ones that are greater than 1 would be 2, 4, 6, 8, and the ones that are less than negative 1 would be negative 2, negative 4, negative 6, negative 8. Given the set of numbers negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, list the numbers that are both, so it has to pertain to both. Greater than 1, so the ones that are greater than 1 are going to be here, and the ones that are less than negative 1 are over here. None of the numbers overlap, so this one would be no solution. So here we have to graph n is greater than 5, so we're going to put an open circle, shade to the right, and we're going to also graph n is less than negative 2, so open circle, shade to the left. These two pieces here fulfill both of our inequalities that are listed above. Over here, we want to graph both of these, and so we have to solve them. It says n divided by 6 is greater than 0. We have to multiply both sides by 6. So n has to be greater than 0. I go ahead and graph that. Over here, I've got n divided by 2 is less than negative 2. We're going to multiply on both sides. So n is less than negative 4. So I'm going to go ahead and graph that. Open circle, go less than. And we've fulfilled both of these inequality statements. When we go here, we have to go through the same process of solving. We get n is less than or equal to 4. Over here, we divide by a negative, and remember, on your quizzes, some of you forgot to do this. When you divide or multiply by a negative, you have to switch your inequality sign. So this would be n is greater than or equal to 9. So n is less than or equal to 4. And I have to fill in that circle because it's less than or equal to. And n is greater than or equal to 9. Open circle, and we'll shade. On the next one, we'll go ahead and we'll solve. R is less than or equal to negative 8. So close circle, less than or equal to. Multiply both sides by 3. R is greater than 3, so open circle, shade to the right. With this statement, we've got negative 6, or n is greater than or equal to negative 6, and n is less than or equal to 4. So we technically have two statements. We could split it up and rewrite. So this is a statement, and then this is a statement. So I'm going to go ahead and I'm going to write these as two inequalities. It has to fulfill both statements, so what you want to do is I'm going to first plot. I'm going to do this. Remember, this inequality, it's opened towards the n, so it's going to be n is greater than or equal to negative 6, and n is less than or equal to 4. It has to fulfill both statements. So here, where n is greater than or equal to negative 6, we're going to shade this way, and n is less than or equal to 4, we're going to shade this way. So we want the overlap. So this whole thing in between is going to fulfill both of these statements. Now the n is greater than -6 would technically continue on. However, we have to stop it because it needs to stop at this 4. So this part I can erase. Okay, this next one, this one's going to be a multi-step inequality. Because this n right here is not alone, we have to get it alone. And so if we get rid of this 4, it's important that you remember this step. You have to add it to this side of the inequality, and you also have to add it to this side of the inequality. So this would be -3 is less than n is less than or equal to 7. And so you could break it up and write it as two separate inequalities. -7 is less than n minus 4, and n minus 4 is less than or equal to 3. Either way, you'll get the same answer. So we add 4 to both sides. We get -3 is less than n, which is represented over here. And if we added 4, we'd get n is less than or equal to 7, which is right here. So if I wanted to rewrite this to see it's going to be n, remember this inequality is opening towards the end, so n is greater than -3. Open circle, greater than, we'll shade to the right. And is less than or equal to 7. So we have to close this, and it's going to be this whole area in between. Here we've got p minus 3 is greater than 0, so +3 plus 3. P is going to be greater than 3. And multiply both sides by 3. P has to be less than 6. So it's just this tiny little area in between that's going to be put on the graph because it has to fulfill both. And means it has to fulfill both. Down here, we'll divide by 5. X is less than 10, so I'm going to go up to 10. Go less than is this way. And add 2 to both sides. And x has to be greater than 3. So we fill in this in between right here. Remember, and means it has to fulfill both, so we're not going to continue in both directions. Here I've got a two-step inequality, so we'll subtract 9. From each side, we've got -5a is greater than -30. Divide by -5. What happens when we divide by a negative? You cannot forget to switch your sign. So a is less than 6. I'm going to go ahead and draw that in. Here I've got to subtract 3 from both sides. Got -a, don't forget that that's a -a is less than 4. Divide by a -1. What happens when we divide by a negative is we have to switch our inequality sign. So a is greater than -4. So it's going to be, because it's and, it's this in-between section right here. Here, this one's or, so we can graph both as they are. So I'm going to go ahead and combine like terms. I'm going to subtract 9k from each side. We get 3 is less than or equal to -3 plus k. Add 3 to both sides. We get 6 is less than or equal to k, or we could reverse that and say k is greater than or equal to 6, because this inequality is opening towards the k. So greater than or equal to 6, and we can just plot that whole thing because it's an or statement. Here we will subtract 6k from each side. We've got 5 is greater than or equal to k plus 8. Subtract 8 from both sides. -3 is greater than or equal to k. We could reverse that and say k is less than or equal to -3 because this point is pointing towards the k. That's why we can reverse it like that. So I'm going to go to -3, fill it in, and it's less than, so we go the other direction. This is where it gets very tricky, so you want to make sure that you're paying attention, maybe going back, replaying this over and over again. When we have a statement like this, this is saying that the distance from 0 has to be greater than 10. So if we're looking at the number line, all right, that means it has to be beyond here, like in the beyond 10 here, and beyond 10 here. So that means x here has to be greater than a positive 10, right here, and x has to be less than a negative 10, because every number on the number line from this 10 over to the right has a distance from 0, remember absolute value is distance from 0, greater than 10. Over here also has a distance from 0 that's greater than 10. So this one is a basic one, but remember, anytime you have absolute value, you have to have two solutions. Some of you forgot that on the Chapter B quizzes and tests. Has two solutions. Over here, what this means, again, this distance right here, this x plus 5, the distance has to be from here over. Okay, so it's got to be, this x plus 5 has to be greater than positive 10. And this distance, this x plus 5, would have to be less than negative 10 in order to get that distance from 0 that's greater than 10. So if we subtract here, x would have to be greater than 5, so I'm going to go ahead and plot that. Subtract 5, and x would have to be less than 5. Or this should be a negative 10. So less than negative 15, which isn't on here. So I'm going to go ahead and add negative 15. So our number line is going to look like this. We'd have 0 here, 1, 2, 3, 4, 5. So x had to be greater than 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. X has to be less than negative 15. I should probably change this color here. So this is going this way, this is going this way. With this next one, I'm going to go ahead and change these numbers, and I'm going to go, no, we can leave it like this. So this distance has to be greater than or equal to 20, which means, actually I will change the numbers. Let's go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So when we first think about it, that distance has to be from here this way. But it would also be, I'm going to go negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16, negative 18, negative 20. It would also have to be over here. So the two problems that we set up would be negative 4x would be greater than or equal to 20, and negative 4x would be less than or equal to negative 20. So remember, we have two different signs. We'll divide by a negative. When we divide by a negative, we switch our inequality sign, so we get x is less than or equal to negative 5. There's one solution. Divide by negative 4. We divided by a negative, so we have to switch our sign. X is greater than or equal to positive 5. So that would be right here, greater than or equal to, shades to the right. Back here, less than or equal to, shades to the left. We've got our two solutions. Here, we want to set up the initial problem, which means that statement has to be further away from 0 than 6, so it could either be there or it could be here. And then you go through and you have to solve. So when you solve, you're going to set up this 3 plus k being less than negative 6, and this 3 plus k being greater than or equal to, sorry, less than or equal to 6. So I'm going to go through and solve. In this case, k would have to be less than or equal to negative 9. So I'm going to go to negative 9, fill this in. Less than or equal to goes this way. Subtract 3, and k would be greater than or equal to 3. So I'm going to fill this in. Greater than or equal to is going to shade to the right. Over here, we've got this statement right here. Again, I'm going to just change all of these. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, 14, 16, 18, negative 20. So that statement needs to be less than negative 20. So what less than means is, I don't want to put that right there. Less than means is that it's going to be closer to 0 than that, which means it would also be less than here. When we do this problem, we've got an absolute value being less than negative 20. What we should have seen from the start is that we were saying that a distance was going to be lower than negative 20, and we know that we will never have a negative distance. So with this one, our answer is going to be no solution, because we can't ever have a negative distance with our absolute value. Over here, we're saying that this v plus 3 is going to be greater than or equal to 1, which means it would also have to be less than or equal to negative 1, because that distance has to be more than 1 away from 0. So I'm going to go through and solve. V plus 3 would be greater than or equal to 1, and v plus 3 would be less than or equal to negative 1. So if we subtract 3, v would be greater than or equal to negative 2. Going this way, if we subtract 3, v would be less than or equal to negative 4. So there are our two solutions. Here's that was the last slide. This is a very complicated lesson. My advice to you would be to ask Mrs. Lima questions during class, start with the harder ones, and then work your way backwards. If you need to ask me a question, use your iMessage to send me a message at sullivan719@yahoo.com, and I'm more than happy to help you. I should be in after school tonight to enter grades. I can't enter grades from Edgerton, so I hope all of you are doing well, and I miss you a lot. Talk to you soon.